We're going to solve the heat pretest number 3 problem here. The power is asking how much power will the heater use. So right away we know this is a heat transfer problem. So we got power is equal to the thermal conductivity times the area times the change in temperature, all divided by the thickness of the material L. So we start writing down what we know. We know that the thermal conductivity, they give it right up here, 0.03. Now as always we got to be careful with the units. It's watts per meter degrees Celsius. The area is the surface area of the box, and the box is giving off heat from all different sides, the left and the right, the back and the front, and also the top and the bottom. So we have 6 sides, and each side has the dimensions of 0.5 meters times 0.5 meters. And if we put that in to our calculator, we can see we're going to have 6, let's turn this off, we're going to have 6 times 0.5 times 0.5, and that gives us a value of 1.5. And if we check our units here, we got meter and meters, so that would be meters squared. Our change in temperature between the inside and the outside of the box. The inside of the box, as it says, is at 20 degrees C, and the outside is at negative 5 degrees C. And if we think about what's the temperature difference, then we're going to have 20 minus a negative 5, which will add up to 25 degrees C is our temperature difference. The last part we need is the length or the thickness of the material, which is given at 5 centimeters thick. Now we have to be careful here because we're in meters. We got meters squared in our area, we got meters squared in our conductivity, so we're going to have to convert this thickness to meters too. So there's 100 centimeters in a meter, so 5 centimeters would be the same as 0.05 meters, just like 5 cents would be $0.05. And now we're ready to put all this in. So we got power is going to be equal to 0.03, and I want to put my units in here to double check things. Meters degrees Celsius times 1.5 meters squared times 25 degrees C, all divided by 0.05 meters. Alright, we got a lot of units to cancel out here. The easiest one is degrees C cancels out degrees C because there's on the top and bottom. Then we have a meter on the bottom here. That's going to cancel out one of the meters squared. So I'll just cancel out the 2 to leave the m behind. And then we got an m on the bottom and an m on top. So all our units are canceling out there. And we're going to be left with watts, which is what we want. So if we put these numbers into our calculator, we got 0.03 times 1.5 times 25 divided by 0.05. And we enter those in and we get an answer there of 22.5 watts. And that looks like a good answer, so let's write that down. 22.5 watts. Well, now that seems reasonable. It'd be a little bit like a small light bulb would keep that box heated, so we'll leave it there.